Welcome to this deep dive, where we extract the crucial insights from recent research to keep you ahead of the curve.
Hopefully ahead anyway.
Today we're tackling a fascinating paper in the rapidly evolving world of machine learning. You're likely seeing more and more about intelligent agents that can understand natural language and then, take action in our digital environments.
Agents that do things.
Well, this paper hones in on a really key aspect of that, how these LLM-powered agents, those using large language models, are actually interacting with software.
Yeah, and what makes this area so dynamic right now is that we're seeing two main ways these agents operate developing almost side by side, API-based and GUI-based approaches.
Okay, so API, that's like the agent speaking directly to the software's code through its application programming interface.
Exactly. Using predefined hooks and functions, whereas the GUI-based ones, well, they learn to use the graphical user interface just like a human would, clicking buttons, navigating menus, that sort of thing.
Right, looking at the screen.
Precisely. And this paper provides a really valuable, maybe even a first of its kind comparison of these two evolving methods.
Okay, so that's our goal today then, to really understand the core differences between these API and GUI agents, how they're built, how they function, and maybe even more interestingly, where they might be heading. Are they going to merge? Stay separate?
Yeah, the paper gets into that convergence idea too. We'll look at their architecture, how they work, and importantly, the strategic side when you might use one versus the other.
Right. So the paper we're digging into today is titled API Agents versus GUI Agents,
Right.
Divergence and Convergence.
Right. And it starts by setting the stage, basically acknowledging the huge progress LLMs have made. They're not just understanding language anymore. They're driving
Actions in digital systems.
Exactly. And the first big wave of this was heavily focused on those API-based agents. A good example, one people might know, is Microsoft Copilot. It uses programmatic interfaces, APIs, to automate tasks within Office apps and so on.
Okay, so these API agents, they've got like a direct line to the software's plumbing, if you will.
That's a good way to put it. Yeah. You tell it what to do, and it uses precise, defined commands, those API calls, to make it happen. It's super efficient, very direct, if those APIs exist and cover what you need.
Right, the if.
Always an if. But then, partly thanks to big advancements in what are called multimodal LLMs.
Multimodal. And they handle more than just text, like images.
Exactly. Text, images, sometimes other data types too. Because of those advances, we've seen the rise of these GUI-based agents. The paper mentions projects like UFO, Cog Agent, OpenAI Operator as examples.
And these guys learn by essentially looking at the screen.
Yeah, they learn to interact by looking at screenshots, maybe using accessibility data from the OS, and then manipulating things on screen in a, human-like way. Clicking, typing, scrolling.
So, okay, if the API agent is ordering directly from the kitchen using a specific order form, the GUI agent is learning to walk into the restaurant, read the menu board, maybe point at what it wants, type in details on a kiosk.
That's a great analogy, yeah. The paper uses scheduling a Google Calendar event. An API agent might make one single clean API call, boom, done.
Simple.
But a GUI agent, it needs to open the browser, navigate to Google Calendar, find the right date, click the Create button, fill in the event title, time, description, click Save. A whole sequence of visual actions.
A lot more steps, more potential points of failure, I guess.
That's definitely one of the trade-offs the paper explores. This fundamental difference in how they operate leads to a whole set of pros and cons.
And the authors are saying there isn't really clear guidance yet on when to pick which one or how to combine them.
Exactly. That's the gap they're trying to fill, providing a systematic comparison to help researchers and practitioners make those choices.
Okay, let's dig into those core differences then. The paper compares them across, 9 key areas?
9 dimensions, yeah. Starts with modality.
Right. We sort of touched on this. API agents.
Yeah.
Purely text-based commands and responses, right? Through those API calls.
Yep. Text in, data structure out, usually. But GUI agents, they have to deal with visual and multimodal inputs. They're looking at screenshots, maybe using accessibility trees.
Accessibility trees. Like a map of the UI elements.
Kind of, yeah. A structured representation of what's on screen. They need that visual grounding to understand where to click or what to type.
Makes sense. Visual grounding is key there.
Yeah.
Okay, what about reliability?
Well, generally speaking, API agents tend to be more reliable. Why? Because they're interacting with stable, defined interfaces. APIs usually have versions, contracts. They're supposed to be predictable.
Supposed to be, yeah.
Right. But GUI agents, they're much more vulnerable to changes in the software's look and feel. A button moves slightly, its color changes, a new banner ad pops up. The agent can get confused or just fail.
I can see that. And you mentioned the multi-step thing, too.
Yeah, because GUI tasks often involve a sequence of actions, there's just more opportunity for one of those steps to go wrong, derailing the whole process. So API agents generally offer more stability if the API is well maintained. GUI agents live at the mercy of UI designers, basically.
Okay. Then there's efficiency. This seems like an obvious win for APIs.
Often, yes. API agents can frequently complete complex tasks with a single command, a single network request. Very fast.
Direct flight.
Exactly. GUI agents have to perform that sequence of user-like actions, click here, wait, type there, wait. It's potentially much slower, more processing overhead, more like a flight with layovers, maybe some delays.
Got it. Availability, though.
Yeah.
This seems like where GUI might have an edge.
Huge edge, potentially. API agents can only interact with the parts of the software that the developers have explicitly exposed through an API. If there's no API for a feature, the agent is stuck.
Which happens a lot, right? Especially older apps or mobile apps sometimes.
Very common limitation. GUI agents, on the other hand, can theoretically interact with almost any application that has a graphical interface, whether there's an official API or not.
So APIs are like having an invitation to specific rooms in the house. While GUI is like having a master key that opens every door, even if some rooms are messy or locked from the inside in other ways.
That's a pretty good analogy, yeah.
Right.
Potential reach is much broader.
But that broad access comes with trade-offs, I bet, like flexibility. How do they compare there?
It's nuanced. API agents are constrained by their predefined functions. Adding new capabilities means someone has to develop and deploy new API endpoints.
More development work.
Right. GUI agents, because they can see any visible element, are theoretically more adaptable. If a new button appears, they could potentially interact with it without needing a specific update. But big but. Actually understanding the purpose of that new button and using it correctly requires pretty advanced reasoning, which is still a major research challenge. So theoretical flexibility versus practical, reliable flexibility.
Okay. How about security? That seems critical.
Very critical. API agents usually offer more fine-grained control. APIs typically have authentication, authorization. You can define exactly which agent can call which function with what data.
More controlled access.
Exactly. GUI agents, though, because they operate at the UI level, often needing broad permissions to see the screen and control the mouse and keyboard, they inherently pose a greater risk. An error could lead to unintended actions, clicking the wrong thing, maybe even exposing sensitive data displayed on screen. It needs careful sandboxing.
Yeah, letting an AI loose with full UI control sounds a bit scary if not done right. What about maintainability?
This ties back to reliability. API agents benefit from those versioned interfaces. If an API changes, it's usually announced there's a transition period. It's generally easier to update the agent to use the new version.
More structured change.
Right. GUI agents, as we said, are fragile. A simple UI redesign can completely break an automated workflow. Keeping those agents working often requires constant monitoring and retraining or rescripting. High maintenance cost.
Okay. Transparency. How visible is what they're doing?
This is an interesting one. API operations often happen server-side, kind of behind the curtain. You send the request, you get a result, but you don't necessarily see the intermediate steps.
Black box sometimes.
Can be, yeah. GUI agents, because they're literally performing actions on the screen like a human would, offer a very visible step-by-step execution. You can watch the agent work.
Which is good for debugging or just understanding what's happening.
Exactly. And it allows for human intervention if needed. You can see it going off track and potentially stop it.
Right. And the last one, human-like interaction. Seems self-explanatory for GUI.
Pretty much. API agents are purely programmatic, code talking to code. GUI agents, by their very nature, simulate human user behavior. Clicking, typing, navigating visually.
Which might make the experience feel more intuitive, maybe. Easier to relate to what the agent is doing.
Could be, yeah. It enhances interpretability, at least. You see actions you recognize.
Okay, so summarizing that divergence part.
Yeah.
API agents win on efficiency, security, reliability when you have good, stable APIs.
Correct.
GUI agents offer that broader applicability, that universal reach, and a more human-like, transparent workflow. But they struggle with reliability, maintenance, and the complexity of visual understanding.
That's a great summary. Understanding these trade-offs is crucial for picking the right tool for the job.
But As you hinted earlier, the story doesn't stop with them being totally separate. The paper talks about convergence and hybrid models.
It does. The authors make a key point. The underlying concepts aren't mutually exclusive. Their strengths can be complementary, leading to these hybrid approaches.
Aiming for the best of both worlds. Broader coverage, better efficiency, maybe?
That's the idea. They discuss a few ways this is happening. One is using API wrappers over GUI workflows.
Okay, what does that mean exactly?
It's essentially taking an application that only has a GUI and building a simpler API-like layer on top of it. Maybe using scripting or even a background bot that drives the GUI.
So you create a function like, say, generate monthly report date.
Right.
And calling that function actually triggers a hidden process that opens the accounting app, clicks through the menus, generates the report via the GUI, and then returns the result.
Exactly. It abstracts away the messy GUI interaction. You get a cleaner interface, maybe better scalability, while still working with the existing GUI app. It's somewhat similar to how modern robotic process automation, RPA, sometimes works.
Interesting. What else?
Unified orchestration tools. Think of platforms designed to build complex workflows where you, the developer, don't necessarily need to know how each step is executed.
So the tool figures it out.
Yeah. Imagine automating an insurance claim. The orchestration tool might use an API call to check the policy details in one system, but then use a GUI agent to update customer info in an older CRM system that lacks an API for that specific task.
Seamlessly switching between them.
Ideally, yes. The paper mentions UFO, which we talked about as a GUI agent, is also being looked at as an orchestrator that could prioritize APIs but fall back to GUI interaction when needed. The goal is to hide that complexity.
Makes sense. Reduce the burden on the person building the automation.
Definitely. And the third area is low-code, no-code solutions. These are becoming really popular.
Right. Visual drag-and-drop interfaces for building automations.
Exactly. Allowing people who aren't expert programmers to create workflows. Under the hood, these platforms are likely using a mix of API agents, like connecting to Stripe for payments or Twilio for messages, and potentially GUI agents for interacting with specific desktop apps or websites, all presented as simple building blocks.
So it blends the speed and scalability of APIs where available with the accessibility of GUI interaction for everything else.
Precisely. It's all about leveraging the strengths of both. The lines are definitely blurring.
It really does feel like the future isn't strictly API or GUI, but rather these blended hybrid approaches becoming more common.
The paper strongly suggests that, creating more comprehensive, flexible, and intelligent automation.
Which brings us to the practical side. The strategic considerations. How do you actually choose?
Right. The paper tries to give some guidance based on real-world factors. When does one clearly win, and when is hybrid the way to go?
Okay, so when should you really favor API agents?
The paper says, go for APIs when you have stable, well-documented interfaces available. That's key for reliable error handling and performance.
Predictability.
Yeah. Also, for performance-critical operations where minimizing latency is crucial, API calls are generally faster than multi-step GUI actions. And finally, if you need tight, controlled access to applications for security reasons, APIs usually offer better mechanisms.
Makes sense. Secure, fast, reliable, if the infrastructure supports it.
Mm-hmm.
So when are GUI agents the better bet?
Often it's when there's simply no API available or the existing APIs don't cover the specific function you need. This is super common, especially with legacy systems or certain mobile apps.
Bridging the gaps.
Exactly. Also, if the task inherently requires visual validation, like in software testing, where you need to confirm something actually looks right on screen, or if you're automating interactions with old proprietary software that just wasn't built to be extensible.
Sometimes it's the only option for those legacy systems.
It often is. And of course, if the task itself involves graphical manipulation, like using a CAD program or a design tool, a GUI agent is necessary.
Okay. And the hybrid approach, when does that make the most sense?
Well, pretty obviously, when your workflow involves a mix of tasks, some are perfect for APIs, others absolutely require GUI interaction. It allows you to use the best tool for each subtask.
Scalability.
And future-proofing too. You might start by automating a process using a GUI agent because that's all that's possible today. But you design your system knowing that if an API becomes available for that step later, you can easily swap it in. It provides an adaptable strategy.
So it's about balancing the strengths and preparing for change.
Absolutely. The paper emphasizes that the strategic choice really hinges on understanding the specific software, the integration needs, the validation requirements, and the long-term maintenance implications.
So to recap the strategy, APIs for stable endpoints and speed, GUIs for when there's no API or visual interaction is needed, and hybrid for combining strengths and adapting over time.
You got it. It's a pragmatic approach.
This paper really feels like it captures a snapshot of a critical moment in automation's evolution, doesn't it?
I think so. These LLM-powered agents, whether using APIs or GUIs, are a significant leap forward from older automation techniques. We touched on RPA earlier. This feels like the next generation, powered by more sophisticated understanding.
Right, moving beyond just rule-based scripting. It feels like LLMs provided the missing cognitive piece. APIs were the natural first step, building on existing web service infrastructure.
Low-hanging fruit in some ways.
And then, as you said, the advances in computer vision and multimodal models open the door for GUI agents to become practical.
Exactly. It parallels, in a way, how human interaction with computers evolved from command lines, which are kind of like APIs, very precise,
Right.
to graphical interfaces. Now we're building agents that can navigate both worlds. And the convergence idea, blurring those lines, that's where things get really interesting for the future of how we interact with tech.
Yeah, the paper's conclusion looks forward a bit too, right?
Yeah.
What do they see coming?
They anticipate that as LLMs continue to get better, both types of agents will benefit. Better LLMs mean better coding assistance, which could make developing and maintaining APIs easier.
Okay.
And more robust multimodal models will make GUI agents better at understanding complex interfaces and handling those UI changes more gracefully, less fragility.
So improvements on both fronts.
Yeah. And they speculate this could lead to seamless integration, maybe even new forms of software imagine tools that can auto-generate their own APIs based on their GUI, or systems that dynamically orchestrate UI elements based on high-level goals.
Wow. Okay. That sounds like a fundamental shift.
It could be. The potential long-term impact on human-computer interaction, software development, user experience, and just our everyday digital workflows, it's pretty significant.
It really sounds like we're moving towards a future where the difference between talking to software via code versus manipulating its visual interface becomes much less distinct.
Increasingly blurred, yeah. More fluid, hopefully more powerful interactions.
Which is a perfect transition, actually, into our novel notions segment.
Ah, yes, where we speculate wildly.
Well, maybe not wildly, but we explore some potential future research ideas inspired by the paper. What's caught your imagination this time based on this API versus GUI discussion?
Okay, so one thing that struck me is that core challenge with GUI agents. Their fragility when the UI changes. It's the maintenance nightmare, right?
Definitely.
So that got me thinking about a research idea I'm tentatively calling introspective agent adaptation through simulated UI evolution.
Okay, introspective agent adaptation. Simulated UI evolution. Break that down for me.
All right. Imagine developing a framework where a hybrid agent, one that can use both API and GUI, isn't just doing tasks on real applications. It's also continuously exposed to a simulated environment.
A simulation of the app's GUI.
Exactly. But a simulation where we intentionally introduce subtle, controlled changes over time. Buttons move slightly, text labels get reworded, maybe a new unimportant element appears or disappears, constant low-level flux.
Okay, like controlled chaos for the UI.
Sort of. The creative connection here is using reinforcement learning, letting the agent learn through trial and error to adapt its action planning in response to these simulated changes, and maybe even using generative AI models to create realistic-looking UI variations for the simulation.
So the obvious goal is train the agent in this shifting simulation to make it more robust and adaptable when it faces real UI updates in the wild.
That's the baseline benefit, yeah. It learns not to panic when a button is a few pixels off. But here's the non-obvious or more novel part. What if, by constantly monitoring which simulated changes cause the agent the most trouble, which small tweaks break its workflow most consistently, the agent could learn to identify high-risk UI elements.
High risk meaning likely to cause automation failures if changed.
Precisely. The agent could proactively flag these elements to developers. Imagine getting a report. Warning. Changing the label on the Submit Order button has historically caused a 30% drop in task completion success in simulations. Consider this during the next redesign.
Whoa. So the agent's failures in simulation become predictive insights for developers.
Yeah. It provides data-driven feedback before real deployment breaks things. And it could even inform API development, highlighting GUI-heavy processes that are so brittle they'd really benefit from a dedicated, stable API alternative.
That's a really neat feedback loop. What's the potential impact and how feasible is it?
Impact could be huge. Lower maintenance for automation, much more reliable GUI agents, better informed API strategy. Feasibility, I'd say moderate. It requires pretty advanced UI understanding, good reinforcement learning techniques for this domain, and the ability to generate useful, realistic UI variations. Not trivial, but maybe within reach.
Okay, that's one fascinating direction. Got another one brewing.
Yes. Shifting gears slightly, thinking more about the user experience side of GUI agents, I'm calling this one contextually aware GUI agents for enhanced user assistance.
Contextually aware, meaning it understands what the user's trying to do.
More than just the immediate command, yeah. The idea is to create GUI agents that can not only perform tasks when asked, but can also observe the user's interaction with the application, understand their likely goals or struggles within that context, and then offer proactive help.
So less of a passive tool, more of an active assistant.
Exactly. Imagine a user is fumbling around trying to use a complex feature in, say, Photoshop. They keep clicking the wrong menus, undoing actions. The agent, observing this pattern within the context of trying to apply a layer mask, could proactively pop up a mini tutorial or suggest a simpler tool for what they seem to be attempting.
Okay, so it infers intent or difficulty from user actions.
Yeah, using the LLM's reasoning capabilities applied to the sequence of UI interactions in the visual context, or if it sees the user consistently missing a required field in a form, it could gently highlight it or explain why it's needed before they hit submit and get an error.
It could even anticipate needs. Like if I always export images in a certain format after editing, maybe it offers that as a one-click option.
That's the kind of thing, yeah. Anticipating next steps, offering relevant shortcuts, providing just-in-time information based on the perceived user goal and context within the application's visual state.
That sounds incredibly useful, potentially making complex software way less intimidating.
That's the hope. It could revolutionize software onboarding, user support, and just general productivity. Make tools feel more intuitive and helpful.
What are the challenges or related fields there? Probability?
Challenges involve accurately inferring user intent and state from relatively sparse UI interactions, avoiding being annoying or intrusive, and integrating this understanding smoothly with the agent's GUI perception and action capabilities. Related fields are human-computer interaction, intelligent tutoring systems, user modeling, probability. I'd say moderate to high. LLMs are getting good at context and dialogue. The key is effectively marrying that with real-time GUI interaction.
Two really thought-provoking ideas there. And as we always say with novel notions, these are speculative explorations, food for thought.
Absolutely. Fun to think about where things could go, building on the solid work in papers like the one we discussed.
Definitely. So let's try to wrap up this deep dive. The key takeaway seems clear. API and GUI agents, while different in how they work, are both incredibly powerful automation tools.
Each with distinct strengths and weaknesses, yeah. APIs for structured, efficient access, GUIs for broader reach and visual tasks.
And that idea of convergence, of hybrid approaches, blending their capabilities, that seems to be where a lot of the excitement lies for the future.
It opens up possibilities for more robust, flexible, and ultimately more intelligent automation that can handle a wider range of real-world scenarios.
So for anyone listening, we hope this gives you a good framework for thinking about these different agent paradigms, whether in your own work or just areas you're interested in.
And the paper itself, API agents versus GUI agents, Divergence and Convergence, is a great read if you want to go deeper. We'll put a link in the description, of course.
It really feels like these developments are pushing the boundaries of human-computer interaction.
Fundamentally changing how we build, use, and interact with software, and how digital workflows get done. It's a space to watch, for sure.
Absolutely. Well, thanks for joining us for this deep dive.
My pleasure.
We'll catch you next time.